Hey everybody, this is Larry. This is me going Q4 of the weekly contest 480. Minimum deletions to make alternating substrings. Hit the like button and subscribe and join me on Discord. Let me know what you think about this one. I'm not gonna lie, I misread this one when I was solving it, which is why I also took longer than maybe I could have. I don't know. I mean, obviously I would have been a little bit faster, but how much faster is unclear. But the thing that I misread was that I was computing the minimum number of deletion or number of character flips, right? So that's basically why. So I actually implemented a whole different thing. But this problem, it just turns out there is a couple of key observations that you have to make. And once you make those, it becomes still annoying, but much more doable. The idea here is that, okay, well, so let's step back for a second, right? For operation 2, what does that mean? We have to compute the minimum number of characters to delete to make it alternating, right? And I'm trying to find my pen. And what that means is actually, right? So let's say you have, I don't know, just I guess they're uppercase A, but whatever, right? So we have something like that, and you're given a range like this, right? Then the number of things you have to delete is actually, if you really think about it, and I wrote unique in the code, but I meant that in a little bit differently. But yeah, this means that this is, let's say this is length, let's not use n, length k, then it is just the number of sequences that there are, subsequences there are, right? And here, as you can see, there's an A, there's a B, there's A, B, A, so there's 5 things. So as a result, the number of things that you have to delete is k minus 5, right? Because everything else that's not just A and B's, the first character, you have to remove. That's kind of the core idea. And once you realize that you can calculate the answer this way, then it just becomes, well, okay, then now we have to figure out a data structure to give me, to allow me to query this to go, okay, well, given these 2 points, we have we have 5 ranges, or what I call segments. And then, yeah, the next thing I did was segments, right? I just kind of convert these into, okay, so you have a segment here, a segment here, a segment here, a segment here, segment here, and a segment here. And then, so then now to answer a query like here, then now it's a very easy way to kind of look at, how many segments it intersects, because also the segments don't intersect. So how many segments this red one intersects with these, right? And that's kind of the core idea, is just setting a structure to binary search. And then it just becomes about maintaining the invariant, which is that, let's say this one's going to be A, B, A, B, A, B, right? And then it just becomes being careful about what you want to do, right? For example, if you convert this B into an A, then now you just have to just do a lot of coding to make sure that it then now converts this to B. I don't know how that happened. A and then B, right? And then also another thing that you may change is, let's say you convert this A into a B. Well, now you convert this into a B, but then now you can merge these 3 into B's, right? So stuff like that. We'll go over it in code, but the idea is that now you just can maintain that. And the thing is that these merging operations, because you only, when you split one segment into at most 3 segments, right? And then you merge, you also only merge to the left and the right. So that means that you only do like 5 or 6 kind of like splitty, mergy operations. It's not cheap, but it is going to be fast enough. And we'll go over it in my code. But that's basically the idea, right? So first I converted to 0 and 1s just because, I don't know, A's and B's are awkward. So I just converted to 0 and 1s. I have the values, and I have a sorted list of the segments. And then here I just kind of construct the sorted list from, and here it contains the left endpoint of the segment, the right endpoint of the segment, and just like the color, A or B or whatever, A, B, or 0 and 1 in my case, right? And then now for each query, we'll do the query first, and this is the easy one, right? You basically do a binary search on the right side, binary search on the left side, and then you just count the number of segments that are inside. oh, sorry, this is the number of segments that are inside. I wrote unique, even though maybe that's a little bit confusing, but this is the number of actual characters, right? There's number of characters, number of unique segments, and the answer, like we said, is just the number of characters minus segment. And at this point, I don't think the code is super interesting. You could write this in a number of ways, but it is just what I said, right? So here we find the index that we're trying to change, and basically we find the segment that it belongs to. Oh, no. This is find a segment it belongs to, we remove it, and then we split it into 3, right? Meaning that, so if we update index, and the index is in a start and end segment, then now we split into start to index -1, create an index by itself, which we'll do later, and then index +1 and end, right? And so that's splitting it up. And then after splitting, you may merge, right? For example, you may split at an edge, then you may merge. So here we merge if possible. So we do a search on the index, and then we kind of just remove right. Well, it merges to the right by, and then it merges to the left, and then it adds the segment at the very end with the things that emerge, and you only get one segment back. And that's it. So what's the complexity, right? Everything here is linear-ish. Actually, this is log n, but yeah. Right, so there's going to be n log n in the setup, and then q is the number of queries, and for each q, we do a constant number of binary search and binary addition and removals. So this is going to be q log n. And that's it. That's all I have for this one. I'll show you my code one more time. This is the type 1 query, right? And then this is the type 2 query. And that's it. I don't know that this is code that I would recommend you like studying and learn, but it's just like an example. I think you should learn to kind of understand what the explanation is and then implement it your own way. And there's a lot of different ways to write this, and you gotta practice to play with it so that you can actually learn for yourself. But overall, pretty okay, hopefully. And that's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in the contest next, including my misreading of the problem next to work. But it was much easier than that. I just kind of bring forward it. Happens, I suppose. All right. AB with J. This is just going to be yeah. It's just going to be a seg tree type thing, right? Maybe even binary index tree. Let's try with binary index tree. Where's my thingy? How do I write it? Why does my binary index tree look like this? No, I looked it up. Whatever. maybe second tree is better, but is it the set version of this? It's been this long time. No, I mean, yes, but also maybe I should just, I don't need prefix actually. I think I need the value. Right. Okay. I did this really weird. Okay, maybe I don't need, I just need this right? Now for X, what's it called? Type. How do I write this with different length? Okay, and then now we want to say that's why I had it. I forgot why I had it, but now I remember. Now it went from 0 to 1, then from 1 to 0. Maybe I could run this better, but it's fine. And then what is that again? Oh, what's it called? Total. It's this, but I have to add a 0, so maybe I messed up here. Or the prefix sum. I think that's fine actually. Something like that, right? Got wrong though. So 1, 0, 2. Why is it 0, 2? This is 0, this is 2. Hey. Oh, it's delete, not flip. Okay, so I thought it was compute the minimum number of flips. This is why I got this. But okay. Huh. I messed up. Now to think again. I totally solved the wrong problem, or different problem anyway. Okay, I definitely did the wrong problem. Oh no. I was like ready to submit and be done. But well, when you do the wrong problem, it's harder to do that. I mean, I think this is fine. It's just what's it called, streaks, something like that. How do I handle it? I mean, now it's just I mean, it's not an I feel like we did this problem very recently. It's just segment, bookkeeping, and then prefix sum on it. It's just really annoying. I don't know if there's anything too interesting. I mean, this would have been interesting, I thought, to be honest. But what's here? You search. Okay, fine. I mean, I just have to rewrite everything. There's nothing about it. You can't do anything about it. How do I want to do it? Okay, fine. Am I doing it right? Is it the other way? I always forget which way it is. Int object not editable. Oh, whoops. How might I do it that way? I mean, I could do it this way, but it's just I'm trying to think whether this is the cleanest way to do it. It's not even that hard, but it's just something like this, right? And then it's just a lot of bookkeeping. This is inclusive. Just prefix sum after that is kind of annoying, right? Is it prefix sum? I mean, it is the sum of the things. It's just the number of segments minus the number of. So number of unique characters. Actually, I guess you don't need prefix sum then. Maybe it is not as bad as, because it is just the number of unique things and then the number of characters that are inside. So maybe this is actually simpler than I thought. I'll make it out to be. Okay, so let's say we have this. I don't know, maybe. Sorry, I forgot. Okay, so then now, okay, I shouldn't have deleted my queries code though, because that was actually doesn't need to change that. Well, maybe just this part I don't need it. Maybe it's fine to rewrite though. If it's 2, then we adjust, right? Index is going to use 1, and then we do a binary search on it, right? Oh, and I want 6 to be a sorted list so that we can change stuff. No. No. course. Okay. So we want to do okay, so 6.bisect left index doesn't matter. It was exactly the same, then okay, yeah, maybe 1 bisect. Right, oh, just it doesn't matter. But then now we want it to be infinity. And then now, it should always be true actually, but then now we take that. Okay, so then now we have 6 of R, right? And then we break it apart. Yeah, this is so annoying. And then now, okay, so then now we go from start and is in how do we move this first? Yeah, that didn't change. Index. Maybe? It's not quite right. Right? Maybe that's fine enough though. Because then now, see, merge if necessary, if possible, right? Yeah, okay, maybe that's fine. Yeah, okay, fine. Right. This should find it, right? So then now we look at -1 and +1, right? So if so 1, 2 is equal to same, then we just merge it, and then we just by removing it. But we have to do the other one first because we're removing it, the index changes. So we have to do r plus 1 first. I guess we don't add this yet. This is a little bit performance, not great, but it's fine, I think. Because we're doing probably an extra binary search for no reason. Maybe 2 binary searches really. But I just want to see correctness. If we time out, then we could fix it. Okay. Else then now. Then now what? We want to search. Yeah, it's kind of annoying, but okay, fine. So it goes to the next one. For the left. And also, maybe that's also goes to the next one for the right. So then now number of uniques it's just this, right? But then now you have to handle the uniques. Total is right minus left plus 1. You have number of uniques. And then if this is okay, that's this. This also goes to the next one. Actually, maybe I'm off by 1, but okay. This is very easy to make mistakes. But okay, so then L, right? Well, no, this is the number of uniques. Well, no, it's only the number of uniques if it's exactly. No, this is the number of uniques, I think. Okay, fine. No, this is the other one. But then now. No, I guess that's fine. That's it, right? Maybe I'm off by one somewhere though. I guess we'll see. Well, I mean, this is off by a lot. Right. I mean, there's a lot of possibility for wrong entries. So let's take a look. That's wrong. No, I mean it merges this, but it didn't merge this for some reason. So this didn't kick off. I don't know what this is. This doesn't even make sense. Oh no, this should give the exact thing, right? Oh, I see. Because I had originally added it, and then that would give me the exact index. Yeah, okay. I changed how I structured it a little bit. So this should give the next one, right? So, okay. Because we didn't add it back. Maybe that should be fine. Hopefully, anyway. Okay, so then now it merges correctly. 02, 10, 01. Is that right? I mean, it's good enough for me to submit. I am not confident about it, but I just don't mind getting a wrong answer. If it times out, that'll be really sad. Okay, so I got a little bit lucky with the, I think, honestly, because this is just a mess of a code, right? It's so hard for me in my head to capture all the binary search stuff indexed correctly. But yeah, okay. I mean, it worked out okay. I mean, I really spent a lot of time on Q3. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Yeah, stay good, stay healthy to get mental health. Good mental health. Man, maybe I don't have good mental health. I'll see y'all later and take care. Bye bye.